Assalamualaikum everyone. Today I will be presenting on the topic of sodium chloride crystallization. My name is Nurul Iffah Binti Dulfiasman and my student ID is 22003166. First, we look into the sodium chloride structure. Sodium chloride, commonly known as table salt, adopts a rock salt structure in a face-centered cubic or FCC lattice. This arrangement involves a two-atom basis with positively charged sodium ions or Na+, and negatively charged chloride ions or Cl-, separated by half the polydiagonal of the cubic unit cell. This layout optimizes stability by balancing the attraction and repulsion between the ions. Now, how they create the bonding? The ionic nature of sodium chloride can be explained by the octet rule. Sodium loses an electron, forming a positively charged sodium plus ion with a stable octet. Similarly, chlorine gains an electron to become a chlorine negative ion, also achieving a stable outer shell octet. This ionic bonding leads to a very stable compound where the ions are arranged to maximize attraction and minimize repulsion. The sodium chloride structure is based on the FCC lattice. Here, chlorine negative ions are at the corners and face centers of the cubic unit cell, while sodium plus ions are positioned along the cube edges and at the center. Each unit cell includes contributions from fractional and whole ions, resulting in 4 sodium plus and 4 chlorine negative ions per cell. This precise arrangement ensures structural stability and efficient packing. This is how we can calculate the atomic packing factor (APF) of the sodium chloride. Now, let us make our own DIY sodium chloride crystal. For making sodium chloride crystal, we just need hot water, container, spoon, measuring cup, and the most important thing is salt. First, we need to prepare hot water and salt. Then, we put a spoon of salt into the hot water and stir until it dissolves completely. Then we continually putting more salt into the hot water until we get the saturated solution of sodium chloride. And finally, we see the undissolved salt resting at the bottom of the measuring cup. Then, we pour the solution into the container and wait until the sodium chloride crystal is formed. After a few days, we can see the result. You may ask how the sodium chloride crystal can be formed. Actually, there are 2 crystallization processes, which are evaporation of salt water and cooling of saturated solution. For the first process, when water evaporates, the concentration of dissolved salt increases until the solution becomes saturated, meaning it cannot hold any more dissolved salt. As the water continues to evaporate, the sodium and chloride ions begin to bond together and solidify, forming crystals. The size and shape of the crystals depend on the rate of evaporation, temperature, and concentration of the salt solution. For the second crystallization process, when a saturated salt solution is cooled, the solubility of salt decreases. As the temperature drops, salt begins to precipitate out of the solution and crystallize. This process is often used in laboratories to grow large, pure salt crystals. And finally, we have learned about the sodium chloride structure, how it's bonding, and what is unit cell of sodium chloride, and also we have learned to calculate the atomic packing factor of sodium chloride, and it is amazing for us to make our own sodium chloride crystal at home. And I hope that you guys enjoy learning from this video. Thank you.